So today we are going to continue from NumPy. So far, what we learned in case of NumPy is that we can create an array of same things, whether it's a string, it's numbers, or something else. But all the elements have to be of the same data types. That was NumPy array, right? Now, question is that how is that relevant to machine learning? How is that relevant to what we are going to pursue further, right? So let me give you a couple of examples and how it is relevant, right? Let's say a vector is a let me just define something called a vector. So vector is a quantity defined by a magnitude and direction, right? This is something which we studied earlier in physics. A vector can be represented as array of numbers called scalars, right? So the list can be quickly used, the array, the NumPy array could be used quickly to represent vectors. So, so what is a vector? Vector has a magnitude and a direction, right? So, so let's take a case of a rocket going up at slight angle. It it might be having a vertical speed of 5,000 meter per second and also a slight speed towards the east of maybe 10 meter per second and a slight speed towards the north at 50 meter per second, right? And the rocket's velocity may be represented by the three values 10, 50, 5,000, right? So what you see is that even though in case of our car, we are able to say that our car is going at 8 miles per hour, right? But we never say whether going forward or backwards or going up or right or left, right? So, but when we are defining the characteristics in a more deterministic manner, more detailed manner, we would have to represent the the velocity instead of only the speed, right? In case of rocket, we have these three numbers to represent the velocity of the rocket in these three dimensions. Okay, so that's how we use the vector. Vector is nothing but list of scalars, and that's what was our array. Array was nothing but list of normal values, right? So similarly, the other use case of a list of the NumPy array is to to define the vectors in case of machine learning. So vectors have many purposes in machine learning, most notably to represent observations and predictions. For example, say we built a machine learning system to classify videos into three classes, right? Good, spam, clickbait, based on what we know about them, right? So if you have to classify a video into three categories, good, spam, or clickbait, then we will have to define the outcome as a vector, right? And not only that, for each video, we would have a vector representing what we know about such a video, right? For each video we will representing as a vector. Okay, so a vector would could represent a video that the length of the video and how many people are watching it, how many percentage of uh, people are watching it for over 1 minute, and it gets 3.25 views per day on average, and it was flagged 7 times as spam. As you can see, each axis may have different meaning. So a video, okay, let me say it in another words. So video has characteristics, or we call them features, right? And features are, it's a list of features. And we generally, as part of our machine learning, what we will do is we will try to convert the feature of anything into list of numbers. If you have to convert an image into vectors, you know what will it be? It'll be list of numbers representing that which pixels are, what is the color of each pixel. So an image is represented by list of numbers. So let's say we have 100 by 100 pixel image, 100 by 100 pixel image, right? So an 100 by 100 pixels image is, let me, okay. So 100 by 100 pixel image will be represented by a vector of 10,000 element. Each element would represent the state of each pixel. Okay. So in the same way, if let's say we are categorizing we are trying to figure out whether video is a spam or not a spam, would be then then what we have to do is we have to characterize the video. What is the length of video? How many people marked it as spam? How many people liked it? How many people commented on it? And sometimes we also represent a whole text as list of numbers. Okay, so this is called the vector is used enormously throughout machine learning. So what we are going to do as part of machine learning is we are going to convert most of the entities into a vector and then apply all kinds of machine learning algorithms on those. Okay, and this is so converting converting something into vectors is really important. So if you think about it, there is something called glob vectors. Okay, glob vectors, right? Um, so what they do is I'll show you what it means by glob vector, or maybe I just drop. Okay, so so to represent a word, what people figured out is that a word can be represented as a list of numbers. Each word can be represented with list of numbers. And that list of numbers is basically called glob vectors. Okay, you give a word, for each word, there's a huge vector representing the number, right? And because of that kind of scenario, it is as it is very much possible to do things like this. The vector representing queen, okay, there's a vector representing queen. If you subtract woman from it and add man to it, okay, women to, and then it'll become equal to the king. Okay, so this is very much possible because of, say, glob vectors that represent each word as list of numbers. Okay, so you could see that there is something called glob vectors. Okay, I'm just giving you a concrete example of where we use machine learning, not this. Okay, so this glob vectors is something we'll cover as part of NLP later. And what it does is it basically represents each word as a list of numbers. Okay, I could show you something really cool. Say, for example, you want to represent frogs, so they will have. So after studying a lot of text, what they have done is they have created the glob vectors out of every word, every dictionary word. Okay, so like for example here, it is showing that the relationship between king and queen is same as man and woman. Okay, similarly, the relationship between between strong and stronger, clear and clearer, soft and softer, dark and darker are similar. Okay, so that's how the vectors are used. Vectors are the most important part of machine learning. So let's say what we want to do is I'll take another example. Let's say what we want to do is we want to classify the cars of the world. We want to do it, we want to figure out that which cars are similar or which cars are not, which cars belong together. So what we'll do is, first of all, we will gather all the data related to cars, and then what we do is we will represent each car with list of numbers. And that list of numbers could be how many gears it has, what speed can it go to, how many, what is its length, what is its width, how many, and how many cylinders, and what is the, how much time does it take to go from 0 to 60. So we'll make a list of all these characteristics of each car. So that will be a vector representing each car. Okay, and all of this we'll try to keep it as numbers, because most of the maths, the way we do it, is done around numbers. So even if it's a text, we might have to convert that into numbers, and that's what is machine learning all about. As part of machine learning, these are the few things that we'll do. We'll first gather the data, convert that data into list of numbers, and then apply all these algorithms in order to get results. Okay, great. So based on this vector, the one we were talking about, the video, our machine learning system may predict that there is a probability, 80% probability of it being spam, 16% being clickbait, and 2% is good video. Okay, this could be represented as the following vector. Okay, so basically we'll be using the list of numbers extensively. A question from Noor: isn't it the same as table car and having fields like engine, color, and other related properties? Correct, it is same as that. So if we'll have a table called cars, which will have each row representing car, and each column of this record will be a number representing the car's properties. Okay, so you can say that every row in a table is a vector. And table, we'll be calling it a data frame. All right, so in Python, a vector can be represented in many ways, the simplest being Python's usual list of numbers. Since machine learning requires a lot of scientific computation, it is much better to use Python NumPy's and ND array, or simply array, which provides a lot of convenient and optimized implementations of essential mathematical operations on vectors. So if you do a quick test of basic list of Python and NumPy's array, you'll find there is a huge difference. Okay, so NumPy's array, we have already covered the basics of NumPy array, and the way we define is NumPy, we import NumPy and then say NumPy.array and provide a Python list. Okay, good. And so vectorized operations are far more efficient than loops written in Python to do the same thing. Okay, and if we do the same thing so what it means is that if we use NumPy's array, they're far more efficient than the loops that we write in Python. In the previous class, I was showing you that if we do some Okay, let me recap a bit. So in the last session, what we talked about was we talked about something called dot operation, right? Dot product operation, whereby we were multiplying two matrices. So we noticed that there was a significant difference between the performance, right? So the operations that are provided by vector themselves are far more efficient. Okay, are far more efficient. All right, let's take this is the one which we talked about last time. So using loops, um, it was giving. This is using loop. We created our own algorithm to multiply two matrices, and here we're using the algorithm provided by NumPy. Okay, and we noticed that when we when we when we when we run it using time it, when we call it using time it, we find that there is a huge difference. There is a huge difference in performance. The one I'll show you. We have two functions. One is called multiply loops and multiply vectors. So the one where we are calling multiply loops, it's taking 4.3 milliseconds, while multiply vector is taking 46 microseconds. Okay, so this is really faster. This is really faster because this is taking far less time. Okay. Um, a further point to Noor's question, I think I forgot to mention that part, that yes, the table can also be represented as a whole vector with a two-dimensional vector. Okay. A ta- all right. So this is same as a vector can be same as a table, just that all the values have to be of the same data type. Okay. So where were we? Where we were. Or you want me to do a quick recap from the beginning? Yes. I've just pushed this script in the GitHub. You could just go to github/cloudxlab/aml. Okay, this is the URL, and inside it you have Python and we have NumPy. Okay, so this is the GitHub one. Now coming back to it, so first of all, we import NumPy, and the easiest way to define a vector is by the way of saying NP, or if we did not provide this, we'll be using NumPy directly. So here we are saying we have created lis NP to NumPy, and we are saying A equals NP dot array. And this is the result we got. Then we say type A. You can see the type of it. And if you want to, we can also convert a tuple into NumPy array. We can we can specify the shape of the shape, as in the dimensions of the vector that we are trying to create, a list that we are trying to create. And here it will create 2 by 3 by 4, which means there will be 2 records, each having 3 by 4 size. This is 3 rows and 4 columns. You see that? So this is how we can create a vector or a list filled with zeros. Okay, then we go ahead and we can also create two-dimensional array like this, or we can also create simply one-dimension array. I'll show you one-dimension array. So you could say np dot zeros, and we could say 4 or 3. So it has created one single dimension array having 3 elements. Okay, so you can see that this one has created two-dimension array having 3 by 4 size. Okay, now so we can check the shape of any array by using 3 by 4, and if you want to fill it with ones instead of zeros, we'll call a ones function. We can also specify the data type of every element. Okay, now if you want to fill with our custom number, what we can do is we can pass the first argument as the shape. You notice that the first argument is a tuple with the dimensions, and the second argument is the value with which you want to fill it. So you can see that it is filled with these numbers. Okay, then so we have filled this 3 by 4 array with pi. Okay, now going ahead, we can also create an array based on starting point, ending point, and some step. Okay, so 10, 12, 14, and so on. So we can also use time it to compare the two arrays, and arrange basically generates the list of things up to but not including the last number, starting from the first number up to but not including the last number. And the default step size is 1, but if you can specify the step size. Okay, a question from Pavan is, why is it showing dot? Okay, so yeah, that's how it is representing a decimal, a number, a decimal number. Okay, good question. So this one is basically, instead of saying 0.0, it's saying 0. Instead of saying 1.0, it's saying 1 dot. That's why. Okay, good question. And yes, you are right. So this is basically a double, or you can say float. A question from Kamal, what does percentage time it x means? It basically means that we are trying to access x. Okay, and what is x? X could be an array. So time it x means how much time will it take to access x. So you can call this time it with anything, including a variable, a function, or anything. Okay. So it's actually just timing. How much time did it take to retrieve this array? Okay, and that's what time it does. All right, although it doesn't make much sense when we are doing the computation. Great. Great. So moving ahead, we can also define our own complex array like this. Here we are defining this kind of array. Question to all of you is, what is the size of this array? What is the shape of this array? Yes, all of you. So we are saying x equals 1 square bracket, then second square bracket, and third square bracket, and then this. So, and then we are saying xx equals np dot array x, and then we are printing the shape. So what will the shape print? So how many records are these? 2, right? 1 and 2. And then how many records are these? 4. So 2 by 4, and each one is having how many elements? 1. So it is 2, 1 and 2, right? 2 by 4 into 1. Thank you, Pawan. So yes, it is 2 by 4 by 1. Is it clear to everyone why this one is 2 by 4? So this is 1 by 1. This record, this particular, if you think about this array, how many element does it have? 4, right? So this one is 4 by 1. Okay, imagine that it was something like this. Okay, imagine that it was something like this. Now, what will that be? Yes, what will that be? It will be basically 4 by 2 by 2 by 4 by 2. It will be 2, 1 and 2 by 4, 1, 2, 3, 4, and 2. All right, great, great. Question from Kamal is, what does 2 by 4 looks like? 2 by 4 will be having 2 elements here. Okay, I'll show you what it means by 2 by 4. 2 by 4 is, okay, 2 by 4 is this kind of an array. So you can say that print, all right, I'll just do again. You see that? Thank you, Lynn. All right, then we talked about something called linear space, whereby it basically generates the numbers distributed between two extremes. Okay, so between 1 and 10, if you want to generate 25 numbers, then we use this. It would include basically 23 numbers between them and including 1 and 10, including 1 and 10 and 23 numbers between them. And these 23 numbers will be equally spaced, equally spaced. So if we have like three numbers equally spaced between 1 and 10, it won't be 1, 5, and 10. It'll be 1, 5.5, and 10, right? 4.5 is the distance between these two, and 4.5 is the distance between these two. Had it been like, say, 0, then it would be 0, 5, and 10. I hope this clears the meaning of linear space to all. Okay. In the same way, we can do the linear space between decimal numbers. So here we are saying between 0 and 5 by 3, generate 6 numbers, including both extremes. Okay, so that's how it is. Now, we can also create a random array by using np.random.random. So using that, we can generate the random array. So here we're saying that give me an array of shape 2 by 3. Okay, we could also say this. You can see that it had generated an array of this shape 2 by 3 by 5. Okay, all right, and we can show the dimensions. We can check the dimensions of x. List has no attribute. Okay, I think I'll have to recalculate this. Okay, so n dimension shows you the total number of dimensions. Okay, we talked about shape, we talked about size, and a question from Minta is, as for range, it is only up to the right side number, right? Up to, not including. So who else does not follow this rule? One is linear space does not follow the rule, but range does follow that rule, as well as when we say slicing of the array and we provide a range, then also it basically does not include the right hand side one. Okay, who else does not follow that rule? One is this linear space, and there are only few exceptions to that. There are only few exceptions to that. Okay. So as a thumb rule, whenever we are talking about a range from here to there, the right hand side is generally not included in Python. Okay. All right. So linear space is probably the only function, and I think you will be able to remember it because it's not generating the range. It is basically generating all the numbers between the two numbers. Okay. All right. So again, moving ahead. Now there is something called, we can convert a linear single dimension array into into something else, some other dimension. Say for example, we have A, which is a one-dimension array, right? It has how many elements? It has 6 elements, right? We can reshape it. We can reshape it to convert it into a 2 by 3. Okay. If this is wrong, as in 2 into 3 is not equal to 6, as in if we say 2 by 4, it is going to give an error. All right. You can see that it has converted it perfectly. If we change this to 2 by 4, it's going to throw an error that cannot reshape array of size 6 into a shape of 2 by 4. So similarly, we can also convert this into 3 by 2 kind of a model. You can see that it has converted that into 3 by 2. All right. So take a look at all the functions by saying either help np or dir np. And we can access the element just using the usual indexing of arrays. And we can also access the range of elements using this. All right. And we also talked about two parts. One is starting here up to but not including this, right? And there was third to it, the third value. Third value means how many to jump. If the third value is negative, it goes in the reverse direction. All right, that's what we talked about last time. And we can also assign a value to a slice of an array. So we can always assign value to a slice of an array. Okay. Okay. A question is, as for what does it mean? What does this mean? Okay. This means, okay, so I'll show you what it means. So we created an array A having these elements. This is a single dimension array. So what we can do is we can take a look at what is inside A. So these are the elements. Now we can say this to access whole of the array, right? If you want to just access the elements starting at the index 1, so we can say 1. If we say that ending but not including the last number, we say 3. Okay, so you can see that 0, 1, 2, 3. So okay, let me again put it clearly. So this is our actual array, 0, 1, 2, 3, 4, 5, right? So we are saying give me 1, 2, 3. So it will start from here up to here but not including 3. Okay, again it's a range selection thing. Now if you want to say that skip a couple of numbers. One is if we say 1, it is going to not skip anything, but if we say 2, it's going to skip. All right, now let me just delete the end position, or maybe here. Okay, so you can see that it is started at 1, was going till 6. Okay, was going to is going till 6, but it is taking a gap of 1, as in it jumping. It is started here, jumped this, because we specified the last element as 2. Okay, and that's how it is. So basically these three numbers is starting point, ending point, but not including, and third one is how many uh, what is the skip. 1 means don't skip, 2 means skip 1. I mean, go to the second element. Okay, go to the second element from here. Second element is 3, then 5. Okay. A question from Kamal is that when we typed A, actually the A is not coming from here. Okay, it's coming from somewhere above. Okay, so So notebook is just a notebook, but only the statement that we execute or we executed in this kernel will have an impact. Okay, so the state of execution is maintained by kernel. If we reset the kernel, the entire thing will the whole memory, the A and all the variables that we have defined so far will go away, even though the notebook will remain as such. Okay. Can I look at the variable? I think there is a list. There is a way to look at. There is there is a way to look at the variables. I saw it. There was a way to look at. There was a way to look at all the variables. Here somewhere one of the variables does have that. This is environment variables. I saw it there, yeah, day before yesterday. Let me just see if locals does the job. Looks like that. Yeah, looks like that. Yeah, I think basically looks like that. Looks like that locals is storing that. I see. I see. We'll have to see that part. It's difficult to read. There was another way to take a look at all the variables, a easier one. Once I find it, I'll let you know. Okay. So again, this place, what you see here is basically a text file. Okay, and there is something called notebook and there's something called kernel. So whatever commands we execute, they're executed on the kernel. And what's the kernel? Kernel is nothing but a Python program which is running in the backend. Okay, so the Python, the kernel is running in the backend, and we are sending all these commands. This Jupyter is sending all these commands to Python kernel, and whatever the result it gives, it is printing it back. Okay, so in the backend, the kernel is what is maintaining a state. This notebook is basically a file that contains all of this as a text. Okay, this and this, all of this as a text, and it's a JSON file. Okay, a question is it being saved in GitHub? So this one, the one which I'm operating on, it is saved in my CloudX Lab account. In my CloudX Lab account, in my home directory, in a folder called ML Python, it is there. So I'll just show you quickly how does it look like. If I log in SSH into my CloudX Lab account, you will see that there is a folder. I have checked out at this place. So, and that's why it is showing me this. Okay. So Jupyter's files will by default will show you all of these, and you can click on this and open it. So right now this is saved in my Cloud Lab account. Okay, GitHub path. Okay, GitHub path. Let me just give you GitHub path. Okay, so this is the place. So you can click on the NumPy. This will do good. All right, now moving ahead. The video will be made available as part of course. You can go to my courses and go to the Python course and you will find the video there. Okay, great. Now, all right, so what we learned was in an array, let's say we have this NumPy array having these elements, and we would like to change few of the values to -1. So you can see that these two values have changed to -1, starting at 1, going up to 3, but not including 3. This is 0, this is 1, this is 2, this is 3. Okay, so all right. So if we can also okay, in our usual Python array, we cannot do an assignment like this. Okay, and also even if we assign a slice of an array to somebody else, if we change that, it will change. This value will change. So a we are saying that a of 1 to 5 is a slice, and then we are modifying a underscore slice with 1000. So this array is getting impacted. Okay. So if we want to do that, if we do not want to change it, we can use copy. Okay. If we do not want the parent one to be changed, we can use copy. All right. So this we talked about. And we can access a particular element in a two-dimensional array by using multiple indexes like this or indexes like this. So here, if we have an array X, let me again create an array X like this. So you can see this is a randomly generated array with a dimension 4 by 5. And if we say X1, that means give me the first record, which is here, this one. Okay, so you can take a look. So this is the first record from here to here. And if we say x11, it means give me this is what is the first row? This is the first row, right? And what's the first element in this row? 0 and 1. This is the element. So we'll get this. So we can either access using this or this. Here we have we will have we basically have to type one element, one square bracket, one character less, and this is far more simpler to read. Similarly, in two-dimensional array, if you want to access the range of the whole array, let's say we want to access this and this. So if you want to access from here to here, basically these two and these two. So what we will do is we'll say, give me 1 to 3, 1 to 2, okay, 1 to 3 actually, and 1 to 3. Okay, let's take a look at this one. We're trying to access, in this case, which part are we trying to access? We are trying to access these two, 0 and 1 and 0 and 1, correct? So we'll get these results. So you can see that Just like normal slicing of arrays, we are able to take parts of it. Okay, so why are we doing all of this? Because we understand very well that vectors are basic part of the machine learning. Every element on which we want to apply prediction or any kind of algorithm, we would have to convert that or represent it like a vector. Vector could be multidimensional, vector could be one dimension, and vector could have many elements in it. And that's where the whole use of NumPy comes into play. All right. So we can also generate a three-dimensional array like this one and access a part of it, a slice of it, just like this. I hope this part is clear. So this one is giving us new array in which the first dimension we are picking up the the two records from the first dimension for 0 and 1, two records from two arrays from second dimension, and these three elements 0, 1, and 2 from third dimension. So okay, let me show you what it means. It's a 5 by 5 by 5 array. How many elements will there be? They're going to be 125 elements, right? So if we are saying give me 0 to 2, 0 to 2, and 0 to 3, then we'll have basically, we'll say, I think will be a little difficult to explain. So we are saying give me 0, 1, 0, 1. I'll show you what it means. Give me this row, okay? Give me this row, and give me this row, okay? And from this row, give me first two elements, 0 and 1, okay? This row, and 0 and 1 means this and this, okay? So you can figure it out. You can figure it out when you look at it, and all we're trying to do is we are slicing a table or slicing a cube into smaller sections. Okay, so that's what we're doing. All right, you can give it a shot and you'll figure it out. Also, we can change we can create quickly the array by reshaping a single dimension. So we just created a simple 3 by 4 array from 0 to 11, and here we are trying to pick up only the rows based on a Boolean array. So we can create another array saying true, false, true. Okay. Basically, in this array, the individual element is a Boolean value. Okay. Instead of a number, it's a Boolean. It can only have two values, true and false. Okay. So if we call this array with such kind of a array, what will happen is it will give us, it will, let's take a look at this rows on. Okay, so rows on basically is showing a list of Boolean flags, true, false, true, right? Now, if we say A and we pass the rows on this particular array as argument, what will happen is it will give us these two records, this and this. Why? Because we are saying true, false, true, true, false, true. Okay, true, false, true. Okay, so Bintav's question is that the script is different. Actually, I'm using this numpy.ipynb. Okay, I've again pushed it. You can check it. Okay, also the variables will be older and you'll have to run the cells again. These are called cells and this is the output. Okay, so what I'm trying to show is that we are trying to pick up the rows selectively. So we are saying this is true, this is false, and this is true. That means it is going to give me first row, second row, and first row and third row, not the second row. Okay, I hope that's clear. So we can pick up elements based we can pick up based on another array of legs. All right. So this gives us a lot of power in terms of slicing and dicing an array. Okay. So we have here. All right. Also, we can just do the addition between the two arrays, and what we're going to show is that we can add a particular value to it. So this is where the rules of broadcasting come into play. I'll show you a simple example. So when we are adding two records, I'm going to, yeah. All right. So now I think rest of the things are clear to you, that we can access how we can access the array, how we can generate them, how we can slice them, how we can update a particular value, and so on, right? Those are the things that we've just learned in NumPy. Okay. Now, the thing is, this one is clear that when we add two arrays like 1, 2, 4, 5, this is one two-dimensional array, this is another two-dimensional array, and we are adding these. So what's happening is 1 is getting added to 0, 2 is getting added to 4, 4 is getting added to 3, 5 is getting added to 4, right? So the result is basically summation of element by element addition between the two arrays. Right? Now, question to all of you is, what happens in this case? Does it give error? Does it only add this to the first one? Does it add this to both of them? Or what happens? Let's say we have two arrays. First one is 2 by 1, 2 by 2. Second is 2 by 1. Now, question to all of you is, then when we do this, what will happen? When we add these two arrays with different shapes, what will happen? Yes, this is so Bintao and Tanmay is right that this will basically repeat 5 and 7, and the result will be 5 and 7 will be added to this, and 5 and 7 will be added to this. So it'll be 6 and 11 here, and it'll be 7 and 12. This is called broadcasting. This is called broadcasting. In general, when NumPy expects arrays of same shape but finds that that's not the case, it applies the so-called broadcasting rules. Okay, it applies the so-called broadcasting rules. Basically, there are two rules of broadcasting to remember. Okay, broadcasting is what? Broadcasting is casting the array in this manner where there are two. We are trying to basically cast one array with a different shape into another shape, right? In order to do the addition or operations. Okay, it's not true only for addition. The same is true for other operations like subtraction and so on, right? Now, so in general, when NumPy expects an array to be of the same shape, but that's not the case, or you can say that in simple words, when NumPy encounters the operations on the arrays of different shapes, it applies broadcasting rules. Basically, there are two rules of broadcasting. Number one, if the arrays do not have the same rank, okay, same rank, meaning one is two-dimensional and other is one-dimensional, or one is three-dimensional, other is two-dimensional, or one is three-dimensional, other is one-dimensional, and so on. Meaning here you can see that this one is three-dimensional, while this one is a single-dimensional. So in these cases, what happens is it will convert this into a three-dimensional array by putting brackets around it. Okay, this is the first rule of broadcasting. So this will actually become, a three-dimensional array of 1 by 1 by 1. Okay, so that's the first rule of broadcasting. So here this is one-dimensional array, and this one is three-dimensional. It'll convert the one-dimensional into three-dimensional by putting more brackets around it. Okay, or you can say it'll convert this into 1 by 1 by 1. All right, so that's the first one. Clear to everyone? So if it becomes 1 by 1 by 1, then it'll be easier. All right, I'll show you more. I think, is there a way to? Okay, I think broadcasting is not there. Let me just define it. Let's say there is an array np dot arange, and we have 6 element, and we are saying reshape into 2 by 3, and we are printing a, right? And then we have b, where we are saying np dot array, and we are saying 1 comma 2 comma 3. All right, let's take a very simple case. Okay, so we have let me, all right, so what we have is a, which is 2 by 3, this mm, okay, I think a better thing to do would be to let me take a better example. Okay, so this way. Okay, and so first one is a two-dimensional array, and second one is a single-dimensional array. So you can see that, and even if we print a dot shape and b dot shape, right? A dot shape and b dot shape. So you can see that the first array A is 1 by 1, right? Second array B is only one-dimensional array, right? So what it'll do is, if we say A plus B, okay, it'll A plus B, the resultant will be a two-dimensional array, right? Sorry, it'll be a two-dimensional array. So if we have let's say C equals A plus B, and we are saying C dot shape, right? So the shape of C is same as A, correct? That means this one has been changed to a two-dimensional array by how? By putting one more square brackets around it. That's all. Okay. I hope that that the first rule is clear. First rule is basically putting one more ones before this one. Okay. Imagine that these were something of this sort. Okay. This one is 2, 4, and this one is 1, 5. And you can see that this one was 1 by 2, this one was 2. So it will basically, this one will become 1 by 2. So Kamal's question is, if we do b dot shape, will it show 1 by 1? Not really. Let me just check. B will remain, I think, as such. Okay. B will remain as such even after the operation. So a question from Gopinath is, so it is by the lowest common denominator. This one is not the lowest common one. Here, it's basically encapsulating array into brackets such that its dimension is increased. Okay, just putting the thing into boxes. Yes, it's Kamal. It is memory broadcasting. All right. So it's like if we want to match something which is in the box and something which is not in the box, you put it in the box and then compare it or operate on that. Okay, so I hope that's clear. So very simple rule, very simple rule. If if the dimensions are different, if the dimensions of two things are different, as in when I say dimension, it means one is two-dimensional and other is three-dimensional. Dimension is total number of shapes, total count of shapes, total count of uh, the total count of dimensions like 1, 2. The overall dimension is counted in this way. So 2 by 3 is basically a two-dimensional array, and 1 by 2 by 3 is basically a three-dimensional array. How many total accesses are there? Okay, so so if the dimensions are not matching, if the dimensions are not matching, all it does is it it converts the second it converts one of them which is in the lower dimension into upper dimension, which is easier, right? All right. That was the first rule of broadcasting. Now, second rule of broadcasting is interesting. Second rule of broadcasting is if we if the size of si shape is not equal, if the shape is not equal and one of them is only one element long, repeat it, repeat it. So here we are adding 1 by 3 with single element. So the single element will be repeated 3 times. Okay. Here we are adding this one with this one. So what's happening is this one is getting repeated 3 times. Why? Because this one is 3 by 3 while this one is 1 by 3. So in whatever dimension it's of one size, that one will get repeated. Okay. So this is 1 by 3 and this is a single element and this is getting repeated. Okay. So this is 3 by 3 and this is 1 by 3 and this is how it's happening. Clear? So this is second rule of broadcasting. Now this one is far more interesting. This is 3 by 1 and this is 1 by 3. Now to convert this, to match this one with this one, what it will do is it will repeat this 3 times. Okay, so it'll become 0, 1, 2, 0, 1, 2, because this one is 1 while this one is 3 in this dimension, right? So this one will repeat 3 times. Similarly, this one will also repeat 3 times. Okay, because this one is 1 by 3, this one is 3 by 1. So to match this dimension with this one, it is repeating this one. To match this one, to match with this one, it's repeating this one. Okay, so this way it is going to add this to this. All right, it'll become 0, 1, 2, 0, 1, 2, and this will become 0, 1, 2 in this dimension. Right? Basically, clone itself to match the other one's dimension, other one's shape, other one's size, you can say, or shape. So on adding a 2D array of shape 2, 1 to a 2D array of shape 2 to 3, what will happen is this one will repeat 3 times to match 2 by 3, right? NumPy will apply the second rule of broadcasting. So what's happening is imagine that we have K and K is 2 by 3, 2 by 3, correct? And if you are adding this K with something which is 1 by 3, what it'll do is it'll repeat this two times. Okay, it'll repeat this two times so that this one becomes 2 by 3. So 100 plus 0, 100, 200 plus 1, 300 plus 2, and then again this will be repeated and it'll become 100 plus 3, 200 plus 4, and 300 plus 5. So basically, this diagram is something that makes more sense. A question from Noor is, what would happen in case of three dimension? In case of three dimension, imagine that we're adding this one. We're adding this one to something that is 3 by 3 by 3, right? So what will happen is this whole slice will repeat. Okay, this whole slice will repeat to match the other one. So first one tries to add one more dimension, and second one tries to repeat elements. So the first rule of broadcasting is in the cases where we are adding two dimension with three dimension and things like that, when the dimensions are different. And the second rule applies when the sizes are different. Does it make sense to you? Correct. A very good point from Kamal. Not all scenarios can be broadcasted. So that is basically kind of, they call it third rule of broadcasting, that in case first and second rule did not work out, give an error. First rule was, if we are trying to add two things which have different set of dimensions, and in that case, just convert the second one, the one which is in lower dimension to upper dimension, and then apply the second rule of broadcasting. If in any of the dimension of this, if the size of one size is not matching and one of them is 1, just repeat it. A different dimension means there is an array which is single dimension, other one is two dimension, right? So I'll tell you. So an array which looks like this is a single dimension array, right? An array that looks like this is two-dimension array. It's going in x direction as well as in y direction, right? And if there was a cube like this, right, it'll also be a three-dimension array. Okay. So I hope that that clear. So this is two-dimensional array. This is two-dimensional array. This is one-dimensional array, and this is three. It could be a three-dimensional array in the same way. All right. Now, so if we want to add this to this, what will happen is this one is in this direction. This is 3 by 4, correct? 3 by 4, right? And this one is how much? This is 1 by 4. So you can see that these are the sizes are not matching. This shape is not matching. This one is 3, this one is 1. Therefore, what will happen is the one that is here, this one is having 1, so this one will get repeated. So this one will repeat. Okay, this one will repeat like this. And then the addition can happen. If we are adding these two, let me just add it somewhere else and then move from there to here. If you're adding these two. All right. So I hope the second rule of broadcasting is clear to you. In case none of this is true. In case first rule and second rule cannot fulfill. Let's say one is having 2 by 3 size, other is having 2 by 4, then it won't work out. Okay, so then it'll throw an error saying that this is not possible. So if we are trying to say match something, say 2 by 3 as simple as 1 by 2 with something as simple as 1 by this, it'll give an error. So I can show you this. If you go here and so if you say np dot array 1 plus 2, 1 and 2, and you try to add it with 1, it says error. Operands could not be broadcast together. Had one of them been single element, it would basically repeat it. It'll basically repeat it. You can see that? Repeat this one 3 times. But if, let's say this one is, say 4 elements, and this one has 2 elements, then also it won't repeat it. It'll say that you cannot broadcast them together. Okay, I hope that that's clear. Yes? No? All right, so this was second rule of broadcasting. In case both of these fail, it won't work. All right, now on the NumPy array, you can compute mean. A question from Kamal is, what is the rationale to have broadcast behavior at all? Good question, good question. So they could have simply done, they could have actually, thrown an error instead of broadcasting, right? So arrays are emulated, or arrays are representation of a vector. And it's very common to do such kind of operations on vector. On vectors, if we are, let's say there are 2 vectors, one is in 1 dimension and other is 2 dimension, we are going to basically cast it into the 2-dimensional one, okay, by just putting a unit distance on one side. That's why, and similarly, the unit vector is something that we have seen in past, that when we add a unit vector with something, it gets added in always, right? So I think the idea of broadcasting is on the basis of linear algebra and the unit vectors. Okay, so that's something that I'm thinking. Okay, so most of it comes from the unit vector and linear algebra, and I think that's where it is coming from. Okay, so when something is single value, it is considered a scalar, and then you can repeat it. And that's the whole thought in broadcasting in the second rule, right? That if something is a single on one of the sides, if one of the arrays is having a single element, then you can repeat it. So a single value can be scalar, and then can be considered a scalar, and then you can repeat it. All right, good, good. So that's the understanding I have. Question from Binda is, what is the sum of A? Okay, sum of A is basically all the elements of A combined together. All right. Let's do a basics of the mathematical operation. You can compute the mean of an array in a very simple way. Okay, so it's going to disregard the shape of an array. Okay, it's going to disregard the shape of an array and compute the mean. All right. What is mean? sum up all the elements and divide by count. Sum up all the elements and divide by count. So there are quite a few useful um, useful functions available to us, like min, max, sum, product, as in it returns the product of elements in a array, and it returns the standard deviation and then variance of the elements in array. There are quite a few useful functions available on an array. Great, great. So you can try to compute these functions on an array, okay? And we can sum across different accesses of a NumPy array by specifying the access parameter of the sum function, okay? So for example, if you want to sum up on a particular axis, then we can sum up in this way. So here we are saying that find the sum across the axis 0. Okay, so what's happening is this is a three-dimensional array, 2 by 3 by 4. So it's computing the sum by 0th axis. Okay, it's computing the sum by 0th axis. So you can see that. So here it's adding 0 and 12. Then it's adding 1 and 13. Okay, then it's adding 2 and 14. And then it's adding 3 and 15. That's what is going on. Right? So it's adding axis 0 means 0th axis, which is the first one, and it's basically adding that one. So if we say axis 1, then it'll be adding the elements between the various the second dimension. So probably it'll add, okay, that I'll have to think about. Okay, so let me just show you what it means. Okay, so imagine that you have array, say 1, 2, 3, and then you have 4, 5, 6, and then you have another one saying say, okay, 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6. Okay, so if we have this kind of an array, all right, let me just show you and try. All right, let me just go to the bottom of it because this is something which we're doing different. So here we're saying A and P dot array, and here we're saying this is okay. All right, so this is okay. All right, this is right, and I'm going to do the same way in case of B. Okay, so if we simply say A plus B, it's going to do the addition, which is good. Now, if we say sum of A, so it'll basically sum up the elements of A, no, not like this, A dot sum. Okay, so A dot sum on array, this A is basically summing up all of them, right? And if we say sum up across the two axes, the 0th axis, okay, let me show you, axis equals 0. So what will happen in case of A? It's adding is basically adding 1 and 4 and 5 and 2 and 6 and 3. If we say access 1, okay, it's going to add these 3 and these 3. All right? I hope this is clear to you. I'll show you a access equals 0. So you can see that the difference between the two. So here it's 579, here it's 615. Access 0 means join them across the rows, as in 0, so 1 plus 4, 2 plus 5, and 3 plus 6. So if you represent the same thing as in the diagram, so what we are saying is add these. This is like, so access 0 means add 1 and 4, 2 and 5, 3 and 6, and access 1 means add these 1 plus 2 plus 3 and 4 plus 5 plus 6. Okay, so I hope that is clear to all. The other important thing that we will study further is transposing a matrix. Okay, so transposing a matrix is basically translating a matrix into from rows to columns to rows. Okay, so if we have a matrix like this and we say dot t, it's going to convert this rows into columns and columns into rows. So 0 1 2, which were the columns, will become the rows. 0 1 2, you see that? So basically this is how the transpose works. Okay, so we can simply say, it's pretty simple. We say a dot t and you get the transpose. All right. Now, now to solve the linear equation, this is something which we studied long back in our school, to solve the linear scalar equations. Okay, the solve function solves such kind of linear scalar equation. So we have, let's say, this equation and we want to solve them. So first of all, we have to represent its coefficient. So the coefficient are 2, 6, 5, and 3, right? 2, 2, 6, 5, and 3. So we created a two-dimensional array and which has the coefficient, and then we defined the answers, right? So 6 and 9, 6 and 9 is another array, and then we say um, LINALG, that is linear algebra, dot solve. This is a part of NumPy, and we can solve such equations easily. Okay, so the solution will be another array. Okay, let me see if I can show you quickly. All right, doesn't look like it has that one. Okay. Oh, okay. So we can import linear algebra like this. Okay, and I'll just show you this part and also commit this. Looks like it's not here. I hope this is clear to you. So when you do that, it is going to solve this. All right. So all right. So if you want to solve a set of linear equations, you can solve them really simply by representing them as a matrix. One matrix representing this part, which is 2, 6, and 5, 3. This is a two-dimensional array. okay, and other one representing the solution, the values, and the values are represented as 2 by 1 array. This one is represented 2 by 2. Had there been three simultaneous equations, what we will do is we'll represent all these three using the 3 by 3 array, and the solution will be 3 by 1, right? And it'll be pretty simple, and you can see that it has found the solution this way. Does it make sense to you? So you can easily solve the linear equations using a package called linear algebra. Let me save this and push it. All right. Okay. Also notice that if we do a dot product of these coefficients, right? These coefficients with the solution, right? Solution is nothing but x and y, right? So you can see that it's an important part. I think it's good enough information to talk about this. So um, we talked about, right, 2x plus, we talked about 2x plus 6y, right? And this is equal to 6. Okay, or can I try it in a better way? So we have 2x plus 6y equals I think here the just give me a second. Let me take a control of this thing. Okay. Okay. So this is the equation that we're trying to solve. And if you notice closely, what's happening is this is nothing but a dot product that we studied earlier, dot product of 2, 6, 5, and 3, right? Dot product of this with x and y, right? So let me draw the matrix around it. I think that makes sense to you now. So you see that? So last time when we were studying the dot product, what we were doing is we were multiplying 2, 6 by xy, right? 2, 6 plus sy. And 5, 3 with xy. 5, 3, so 5 into x, 3 into y. That's what it is. So basically this is equal to this one is equal to 6 and 9. 6 and 9. So this is where the meaning of dot product comes into play. Okay, so this set of equation that you see, 2x plus 6y is equal to 6, 5x plus 3y equals to 9, the same thing is represented as a dot product. This is where the meaning of dot product comes into play, that we are going to multiply 2, 6 with xy, 2 into x and 6 into y, and then we add them up. 5 into 3, 5 into x and 3 into y, and then we add them up. So the same set of equations are written in the form of in the linear algebra in the form of these matrices. Okay, so which means that if we multiply this with the solution that we got, we should get the answer. So the solution that we got here, if we say coefficient dot solution, right? So we should get these dependent variables, right? That's what happened just now. So this into the solution resulted in 6 and minus 9. Here it is minus 9, sorry. Does it make sense to you? So this is where the meaning of dot product comes into play. Okay, and these days you might be seeing a lot of these problems that people keep on putting on the LinkedIn and here and there, showing 3 bananas plus 2 apples is this much and so on. Those are nothing but kind of extremely simplified linear equations. Okay, so let's take a break for 10 minutes. Hi everyone, I'm back. So should we start now? All right, so let's start. Great, great. So what we were talking about briefly before the break was related to solving the linear equations, right? So here we gave an example, a very simple example of two variable equations, two variable equations, as in we got 2x plus 6y equals 6, and we have another equation 5x plus 3y as minus 9. Now, how do you solve this? The way we earlier solved was you by multiplying 3 into 6 and 6 into this one and then compute it. So you'll notice that a lot of this work is actually just like the vectors that we just studied. And the fact is that whatever linear algebra that we're talking about, these arrays and the multiplications, all of this has come from trying to solve such kind of equations. Okay, so this set of equation is generally represented as this. It is represented as this coefficients are represented as 2, 6, 5, 3, which is 2, 6, 5, 3, as a two-dimensional array. It's a 2 by 2 array. Then dot product x and y, x and y. What it means is that this row will be multiplied with this column, and all of the values will be added after multiplying, and then second row will be multiplied with xy, and then afterwards it will happen. Okay, so it'll be 2x plus 6y and 5x plus 3y equals 6, 9. Okay, so once we find out the value of x and y, we can test if this really works. So what we did was we used the package called linear algebra, linalg, to solve these linear equations. So we said solve, these are the coefficients. This we represented as a 2D array, and this also we represented as a single dimension array. Okay, so this one we represented as single dimension array, and we said these are coefficient, these are the dependent variables, and it found the solution for us. Okay, and that's how. All right, so yes, we are still in the first part of the course. Now, just to check if this is working fine, so what we're doing is coefficients dot solution. Coefficients was 2, 6, and whatever solution came was the value of x and y, and this is actually equal to 6 and minus 9. All right, I hope this is clear to everyone. In order to solve such kind of equations, most of the linear algebra has been created. Okay. All right, so we will talk about more linear algebra maybe later point of time, as in when the problem arises. Also, we will try to avoid too much of maths during the course. We will try to see if we can get these things done using the packages available. So whenever need arises, we will digress into the individual concepts, because what we have seen is that if we just go into too much of theory, you will kind of lose interest and you may not find it significant. So we will digress during the course whenever need arises for anything. Say if we want to understand what does it mean by statistical inference, or what it means by the transpose, we will recap all of these ideas what we've learned so far whenever need arises. All right, so let's go briefly over pandas. So we are going to we're basically covering only those parts which are mandatorily required for remaining course. Okay. All right. So the second part is the pandas. Pandas is okay. All right. So let's start with pandas. So Pandas is a library just like NumPy, and there's a matplot. We talked briefly, but we'll go over a couple of more functions today. So Pandas library provides high performance, easy to use data structures and data analysis tools. In very simple words, Pandas provide you the same abilities as R does. R provides you this data frame which you can operate on and slice and dice the data. In the same way, pandas also does that. Okay, so the main data structure of pandas is data frame. It is an in-memory two-dimensional table. It is like a spreadsheet with column names and row labels. Okay, here every here it is not like NumPy. NumPy, all the elements in the whole matrix or array have to be identical, have to be not identical, have to be of the same data type. Here, that's not the case. Okay, here we will understand the differences as we go ahead. So pandas is for general purpose computing, uh, specifically for the data slicing and dicing, while the NumPy was basically for the representation of two-dimensional vectors. Okay, all the elements must be of the same data type in NumPy. Okay, so both Pandas and NumPy work together pretty well. They are not competitors, they are complementing each other, and they are quite useful libraries. So Pandas is basically the core of Pandas is basically a data structure called data frames, which is equivalent of data frame in R, which is equivalent of a data table in databases, and which is equivalent of the spreadsheet in Microsoft Excel. Okay, so many of the features available in Excel are available programmatically, like creating pivot tables, computing columns based on other columns, and plotting graphs. All right, so here, so many of the features available in Excel are available programmatically, like creating pivot tables, computing columns based on other columns, and plotting graphs. All right. So in general, Pandas provides three kind of data structures: series objects, which are nothing but arrays in which you can define the column names. Okay, they are very similar to a column in a spreadsheet. Okay, data frame objects are 2D array, two-dimensional table, which are similar to a spreadsheet. So data frame is composed of series inside it, and the panel objects. Panel objects are dictionary of data frames. Okay. Now, Gopinath's question is, given what pandas could do, would one still use NumPy? Yes, we would use NumPy because there are many differences. So data frame objects are strictly two-dimensional tables, while NumPy array are multi-dimensional, right? So whenever we have to do some kind of mathematical operation, we will still be using NumPy array. Whenever we have to take the raw data and try to process it and so on, we will be using pandas. Okay, and both of the data structures, NumPy array and the data frame and series objects, they are they are compatible with each other. Okay, they're very compatible with each other. So we will be learning, we'll be using both of these together. All right, so we'll start with series object. Series object is very similar to an array. The only difference is that every record has a name. Every row has a name. Okay, so here we're creating a series object from a Python list, and this is what we get. Okay, let me just pick up this. So the easiest one is creating a series object. So we import pandas as PD. Okay, and then, all right, how do you start editing it? Okay, so you can see that we are importing pandas as PD, and then you can see that we are able to run that. Good. So here you can see there is a name for every record. Series is like a column here. Series is like a column. Okay, we can do things like square on it. We can do things like square on it and using NumPy. Okay, so even though S is a series object, we can operate NumPy on it. Okay, so NumPy is able to square it. So every element of this is squared. 2 became 4, minus 1 became 1, 3 became 9, and 5 became 25. Also, we can do normal arithmetic operations. Okay. In the same way, um, we are also able to do broadcasting just the way we did in NumPy. So 100 will be repeated so many times. So our S is this, right? 2 minus 1, 3, and 5. So 2 added with 1000, 1000 value is added with 2, then minus 1, then 3, and then 5. Okay, so the same rules of broadcasting that applied earlier also applied here. Similar laws. Okay. Also, we can quickly compare the whole series, object. So we're comparing S with 0. So this returns S lesser than 0, 2 less than 0 is false, minus 1 less than 0 is true, and so on. So it returns another series object, which is made up of booleans. All right. Also, the series object has a name. By default, is 0, 1, 2, 3, and so on. But you can pass, while creating series object, you can pass a list of names. This list of names should be same size as the actual list. So we are saying create a series object from this Python list and put these names on it. So basically it created a series which can be accessed based on the row name. So Alice is a row name for this one. These are called indexes. All right. So what you have is you have these values. We can now access a particular element. These are row names. So the way series, the way we look at, good point, Noor, thank you. The way we look at series is we always look at series as if it's a column. Okay, it's a single column of Excel sheet. Okay, all right. A question from Tanmay is that index has to be unique. Yes, they have to be unique. Okay, it looks like, yeah, it looks like a hash table. Yeah. So here we can address a particular value based on either a index like 0, 1, 2, or using a named index. Okay, it's a named index. So we can access this particular value 83 either saying s s2 1, this is 0, this is 1, or saying s2 bob. This will give us the same results. So you can see that it has given us 83. It is recommended to always use LOC attribute when accessing by label and iloc attribute while accessing by integer. Okay, so you can, whatever we did here, you can also do it using lock. This is safer than this one. We can create a series object from a dictionary. Okay, we can create a series object from a dictionary. The keys will become the index and these will become the column values. Okay. Also, also we if we do not provide sorry, we can also pick up only certain keys by providing an index. Okay, so weights contains so many values here. We have Alice, Bob, Colin, and Darwin, while index is specifying only Colin and Alice. That means it will pick only those two columns. All right, so this is how it works. Okay, so let me run it and show it to you. So you can see that it has skipped everything else from the weights. It is skipped, it kept Alice, it is skipped Bob and Darwin, right? A question from Gopinath. If you can access the values without lock and ilock array, is it better coding to use lock and ilock attribute? Are there any pros and cons in terms of best practice coding? So people generally prefer it. I mean, as per them, using lock and ilock is better. Okay, but I prefer it using this way. Okay, all right. So now, all right, I was going to show you. If we want to add two series objects, it will automatically align based on their names. Okay, index, as we specified, is used in far more ways than we think of it. So imagine that we are trying to use S3. S3 is this, and S2 was, okay, let me just check what was S2 and S3. So, okay, let's see. So this is S2, okay? Alice, Bob, Charles, Darwin, and something. Here, there is no colon in S3. Sorry, uh, S2 contains Alice, Bob, Charles, and Darwin. while S3 contains Alice, Bob, Colin, and Darwin. Okay, it doesn't have Charles, it doesn't have Colin, right? So these two are kind of non-matching ones, right? These two are these two series objects are non-matching ones, but when we sum up these two, what happens is based on indexes, it sums that based on indexes. So Alice has been summed up, Bob has been summed up, you can see that, while Charles and Colin is not a number. Okay, so this is where the index is used. Index is used for alignment of the records. Okay, which one is getting added to which one. So index is used in those cases. Okay, and you will see that index is very useful, and index is something that is the primary key reason for using pandas. Okay, a question from Gopinath is why does it change the data type to float 64 when no decimal notation was used in either S2 and S3? A very good point, a very good point. And yeah, so by default, when you're adding things in pandas, what it does is it makes that as a float 64. Okay, to accommodate for all kinds of numbers. A question from Tanmay. Charles should have been 112, right? No. In case because Charles is being added by non-number, and that's why it is happening that way. Charles is being added with a non-number. Therefore, it is marking at as not a number. NaN is not a number. Good question. Okay. Instead of assuming the the zero value of Charles from the second data set, it is basically marking as non-number, not a number basically. Okay. Question from Tanmay is how can we default it to 0? How can we default it to 0? So you will have to create another index with 0. Okay. Or maybe in the addition, you could mark something. Okay. All right. So most likely we'll have to create another index with marking at 0. Another question is Colin is 86. Colin was 86 in B, but when it got added with this one, there was no Colin in in S2. There was Colin in only S3, and that's why it became not a number. All right. So all right, now comes the idea of a data frame. You can create data frame from the series objects in the following way. You can say pd.data frame and pass a list of series objects. Okay, so we have S2, S3, S4. Okay, we have S2, S3, S4. S2 looks like this: Alice, Bob, Charles, Darwin, and these are the values, these are the indexes, and this is S3 and this is S4. And when we create a data frame, what would happen is it would impose the index on all. Okay, so Alice, okay, so there are, when we added these series objects, they became like this. So we have one series object here. So it's a data frame with index like this. Okay, index like this. So the horizontal index became the the index became the horizontal. So we have Alice, Bob, Charles, Colin, and Darwin as the index here, and this is first series object, this is second series object, and this is third series object. Okay, so this is the way we are able to create tabular structure by imposing multiple series objects together. All right. So this is the way we can create data frame. And again, what is a data frame? Data frame is a tabular structure in which we can access the individual in which is made up of it's a tabular structure made up of series objects having index. All right. Okay. Do I make sense, or should I explain again, everyone? Are you clear how to create data frame from the series objects? Okay. Please make a note that series objects must have the indexes. Okay. If they had completely different set of indexes, those many columns would be created. Okay, those many indexes will be created. You can see that when we are creating data frame from S2 and S3, S2 is this and S3 is this. A new column is the total union of columns is being created. So Alice, Bob, Charles, Darwin, and one more Colin will be created next time, right? So all the unique columns from all the data, all the series objects will be picked and marked as this. A question from Gopinath is, can the row labels be changed for the data frame? Can the row labels be changed for the data frames? Mm, yes, we'll talk about it soon. Okay, great. All right. So therefore, before creating a data frame or before adding things, we have to make sure that we are marking things with the right index labels, right or correct index labels. Otherwise, if things are misaligned and the values are getting added in a wrong way, it would not be of much use. All right. So like for example, if we had S2 in this way, right? And S5 is nothing but this. And if we add S2 and S5, what would happen is all of the values will become not a number. Got it? Because they have different indexes. So the final index will be composed of both, but the values are not a number. All right. So in case we want to initialize, so I think this answers Tanmay's question, that what if we want to default the values with a certain number? Then what we can do is we can create a series object with a particular number as a value, and then the second argument is the list of indexes. In that case, it will have three values, and all these three will be having this index. So 42 here. So 42 has been the value for all these three keys or these three indexes. All right. So here we are creating. Yes. So 42 is the default value if no value is provided here. A question from Tanmay is, so 40 is so question from Tanmay, can we pass Python list here as well? These are Python list only. You're right. This is a Python list. This is another Python list, and so on. Also, overall, we can give a name to the series. Okay, we can give the name to the series. Here we are giving the name to the series as weights. Okay. Also, it's very simple to plot a series from pandas. Imagine that we are using, say, import matplot. We are using a matplot, and the way we use is that import matplotlib.pyplot as plt. This is the first import we do. Okay, and we are saying temperature equals this. It's a list of values. Okay, and here we're saying that our pd.series is this temperature and the name is this. Okay, and we are saying s7.plot. So it's able to plot the chart. You can see that. It's very simple. We can plot a series in a very simple manner. We can just simply say series.plot and it will automatically pick up the pie plot. Are you able to do so? Okay, so the x-axis is index. Good question, Tanmay. So x-axis is the index and the y-axis is the value of series. Question from Kausal is, can matplot not plot itself without Pandas? It can, of course. It can. So the only point I was trying to make is whether matplot, NumPy, or Pandas, they are very, very compatible with each other and they work together pretty well. All right. Now moving on to the data frame object. So what we learned so far is that there are series objects, and series object we can operate just like we operate on arrays, as well as we can access series object like a dictionary as well. Binta's question is, why doesn't it show the name temperature? So yeah, so even though we have given the name for the series here as temperature, but still it doesn't show. We'll have to enable the labels probably. I think that way it will work. Okay. A question from question from Tanmay, can we load from CSV into data frame? Good question. We will show that today. All right. Great. So this is how we do the plotting of the graph. All right. So the data frame objects can be created out of series objects. Okay. Either by just concatenating the series objects or by creating a dictionary of series objects. Okay. Here, series object, we have an index here. You can see that. Series object we have created here. And we have given them a name. So every series object has got a identification here, and that's how we have created the data frame. So data frame here is being created from a dictionary of string and series objects. Okay, dictionary and series objects. So you can see clearly that it has created a data frame. So the important part of the data frame is either we can have numbers here or we can have names. If we do not provide names, it will by default take it as numbers. We'll see how we can create without the names. Okay, right now this is the easiest way and the nicest way of creating the data frame. by using a dictionary of series objects where the keys are the names of series objects and the values are series objects. Okay, so we created the data frame from series object. Is it clear? Is everybody able to do it? All right. So you can see that we can quickly access a particular column or a particular row. Okay, now you can quickly access a particular column. Here we are accessing birth year. If we use dot lock here in case of people, we will be able to access based on the column. Okay, so you see that? So if you want to access a particular column or row from a data frame, it's really sleek. Is there some logic handling to treat all NaN errors with another value using maybe some if condition? Right, right. We'll talk about it as we go ahead. A question from Bintao. Value of data frame can be different. Yes, the values in data frame can be different. Okay, just the series objects should have all the same values. But there could be different kind of series object in a same data frame. So here we are accessing birth year. So we get 1985, 1984, 1992. We got a series object. Similarly, we access this one and we got the series object containing the indexes birth year, children, hobby, and weight and their values. Also, we can access the multiple columns easily by saying people and by calling people with an array index and passing a list instead of a single value. So we are saying, give me the all the records with the columns birth year and hobby. Or you can say, right? So give me a series object of birth year and hobby. Okay, so this way we can get those columns. Okay, if we pass a list of columns and or index row labels to the data frame constructor, it will guarantee that these columns and row will exist. Okay, so if we are saying that this is our people dictionary, okay, this is our people underscore dictionary, and these are the columns, so it will put empty, not a number, in those columns which are not existing here. This dictionary contains birth year, Alice, Charles, and so on, but it doesn't have, say, it doesn't have height. So it has put not a number in that column. Similarly, we could also put the index names. Okay, it will pick up only those records. All right. Let me go back to people dictionary. Where did we define it? Never mind. So this is our people's dictionary in which there were weights and so on. Okay. So this is a dictionary of series objects. And all right, let me put it this way. All right, here. Good. So people dictionary contains the dictionary of many series objects. And from that, we are saying that we are picking up these columns only, meaning only these series objects. And these are the indexes of each of the series object, okay, that we are picking. So this is what we get at the end of it. Okay, so it will basically put not a number in that column. A question from Tanmay: data frame is in the memory, so how big it can be? That's a very interesting question. Question is, since data frame resides in memory, how big can it be? The answer is however big your process can be, as in how much memory can your process is allowed on this operating system. And how much is that? That's a function of how much is the total memory of your system, and are there any constraints imposed by operating system. Okay, so in the best case scenario, the data frame can go up to the RAM available in your machine. The data frame can only go up to the RAM available to your machine. Okay. All right. Now we can access we can access the rows very easily by using dot lock. A question further is from Tanmay that so then can split or compress data frame? Yes, you can split or compress data frame, or you can load the data frame partially. We'll talk about it. Okay. All right. So we can either access the columns just like the way we used people and birth year or children, or if we want to access the rows, we can use dot lock to access the rows, right? And ilock is for accessing in the same way without the names but using the indexes. Okay, so this is what it is. And in the same way as we were accessing the Python list, in the same way, we can also access the values in ilock using the range. Also, we can pick up the columns selectively. We can we can pick up the rows selectively by using these array here. So here the people is Alice, Bob, Charles, and we are saying true, false, true. That means pick Alice, not Bob, but Charles. That's what will happen here. So this is what it is. Okay, so this way we can pick the records from people based on true or false, based on a Boolean array. Okay, now here's interesting use of it. Here's an interesting use of it. So we have, let's say, this. So I'm going to comment this. So you can see that the where is people? People is this. Okay, and I'm saying people birth year. people birth year is this. So we are saying people birth year less than 1900 here. So what did it say? Oh, I did not print it. Sorry. I did not print. Okay. Now you can see that here when I said array equals this and printed this array is true, true, false. Okay. Now we can say people and array. So here what we get is we are able to use it like a where clause. You see the result? So it's giving me the records in which birth year is less than 1990. Birth year is less than 1990. Okay. So it is same as this. So if you want to pick up, if you want to select the rows, if you want to select the rows whose value for the rows in which a particular column's value is lesser than something or greater than something or some other condition, we can do that. It is equivalent of where SQL, a where clause in SQL. Okay, this is very much equivalent of where clause in SQL. Okay, so what it actually did was it created an array of flags and then we passed that array of flags and we got the results. And of course, we can have multiple conditions here. Let me see if we can do that. Let me try. I haven't tried multiple conditions in this. Did it work? No, it did not work. Let me comment it, comment it. The truth value of series is ambiguous. Use this or use a dot bool. I see. Does it work this way? This one is right. Okay, I think that it should be possible. All we have to do is create two separate arrays of the Boolean values and then put the AND operator between them and then use that array in the people's as an index. All right. So Gopinath's further question is, can we use XOR, XAND logical condition for filters? Is there a such thing? Yes, you should be able to do that. Okay, then my question is, what if birth year was a string or we need a date conversion? So what the way we do is we create another column with the after converting and then apply these operators. Apply these operators. Okay. We can also keep on adding and removing columns from a particular data frame. Say, for example, we are creating, here we have, let's say, this is our people, right? This is the data frame called people. It has got these rows and these columns, okay? These rows, these columns. And here, And here what we have is we are creating a new column called age. Okay, I'll delete some of the part in this. This is a little dangerous because it'll going to delete my data. Okay, this part I'll remove from here. Okay, right. So what we see here is we are creating a new column called age. New column called age here. By applying this computation here, we are saying 2016 minus people's birth year, or we could say simply 2017. Now it's another year, so we are saying this. Okay. Now, so this is the age of people as of 2017, and how are we computing is using another columns. Okay, and we're printing the people's age here. This is just for printing the dashes 4 times. And then we are saying people over 30. This is the column name. You can see that column name could be the column name could be a string with spaces, and we are saying people's age greater than 30. Okay, and then we are further printing this part. Okay, and we are printing people. So you can see that in people there are 2 more columns, over 30 and age. And here we're just printing this column called people over 30. All right. So you can see that we have just created 2 more columns in the data frame. A question from Amin, can we use if else? Very good question. So instead of using if else directly, what we will do is we will create the columns dynamically using the lambda operation, and then we can do anything we want. All right. And of course, we can delete a particular column easily by using the del operator. We could say del people this, or we could pop. Either of the methods can be used to delete a particular column. Okay. Where did it go? Here. So this is how you can remove the columns, and this is how you can add the columns. Okay. So it has deleted the columns. Okay. So here the birth year was deleted. Okay, and then children also. There's not much of a difference between del and pop. In case of del, when you use pop, it returns the deleted value, while in case of delete, it just deletes the value. Okay, that's the difference. So if you are trying to remove something and use that removed part, use pop. If you are just deleting it, just use del. Okay, del doesn't return anything. Okay, so when you are trying to add a new column, it must have the same number of rows. Missing rows are filled with NaN. Okay, and extra rows are ignored. So if, let's say, we are trying to add one new column called pets, and we are defining a series, we are saying people pets equals pd.series, and we are saying Bob is 0, Charles is 5, and Eugene is 1. So this one is extra, and it doesn't have the value for Alice. So Alice is kept as none, while the Eugene is deleted. You can add a new column using insert method as well. So we are here inserting a new column having, let me just show you what it means here. Yeah. So you can see that we are inserting this particular column at a location at this location. We are saying 0 and 1. At the first location, we are inserting this column called height with these values. So we can insert the columns this way, other than just adding a column. So if you want to explicitly insert a particular column at a particular position, we can do that using this. Okay, using insert. Now this is interesting. This one is interesting part. You can create a new column using assign method. Using assign method, you can basically use a programmatic function, just like map in Python, and it just like map in other frameworks like Spark and Hadoop. So here also, in the same way, we can create a new column using a function. So we are saying that people.assign square equals my function. And what my function does is it goes over, basically my function creates a new value from as the square of height. Okay, so this function is going to be called on every row of this data frame. This function, my function, is going to be called on every row of this one, and then whatever my function returns, that becomes the column value. So you can see that what my function does is it picks up some value from this row, okay, and squares it. Okay, so it's squaring 172. So this one returns a single value. You see that my function is returning only a single value. Okay, so how many times this my function gets called? This function is called on every record. Okay, it'll be called 3 times. So my function will be called once for this. Okay, then for this, then for this. So, and the name of this new column is going to be square. So square equals this into this to the power 2, which is this, which is square of this one, and then square of this one is here, square of this one is here. So using a sign, you can create these columns. You can create a column dynamically where each row's value depends on other rows. Okay, so you can notice that this function gets x, a variable called x as argument. X is nothing but the current row on which this function is being called. Okay, so it can only access, this function can only access the whole row on which it's being called for. So when we call a function via assign, that function will be called on every record, and whatever value it gives, that will be assembled and will be used for the column value. Is this clear to everyone? Assign. Using a assign is a very powerful function. Using assign, we could do anything. Okay. Using assign, we can also do all sorts of things. Remember Tanmay's question was there, where can you cast this thing into something and then compare it with something? And then there was another question where can you, create multiple conditions and so on. So using assign, you can do that. You can create a new column by processing every record and so on. Right? This is very much similar to what map or similar functions work like. Is it clear to everyone? So my function will be called for every row. Every row. The argument that you get in your function is a row. This X is a row. Okay. Let me just change the variable name. We can just call it row. It doesn't matter. All right. see that. So as an argument, your function would get the entire row, and your function's duty is to return a single value, either based on row or based on some other characteristic. You could also pick up a random number and return. Okay. All right. So in the same way, you can assign, you can create, create really complex uh, columns. Like here, we are saying that the body mass index equals weight divided by height divided by 100 and the square of it. Okay, and so on. And then we are saying that the we are creating one more column called overweight, and we are passing this. Okay. Also, if you are very comfortable with SQL kind of query, you can simply use a method called query and put your condition in the string form. So here we are saying that people.query equals people.query, and then we're passing a string containing the whole query. Okay, a question is, where does df come from? Df is the name that is given by you. Okay, so it is the name of the argument of the function, because you can define any, you can put any name in the argument, right? The way we kept row here and so on. So what is this function is going to do? Assign is going to call your function, my function, on every record of an existing data frame. And basically, when I say call on every record, it means it's going to call your function, pass the entire record to your function, and whatever value your function is returning, that becomes the column value. A question from Gopinath. So is it the new column via assign method in memory now? Yes. So it's a whole data frame that's in memory and can be used in later calculation. Yes. All right. So you can query a data frame using the query method, and it allows you to basically frame SQL kind of syntax. Also, sort we can sort a data frame. By default, it sorts the rows by their index label in ascending order. We can reverse the order by saying ascending equals false. So here we are saying that sort this data based on the index, but in a increasing manner. So Charles came at top, then Bob, then Alice. Okay, so in case we say in place equals to true, then this existing data frame is updated. Okay, so that one. So here you could always say that if you say in place equals to true, it's going to update it in the memory. So meaning that the previous values are going to be updated. And of course, you can combine these together. Okay, good questions. So you can see that now once we have sorted it, if we print the people, this data frame, it is sorted here. Okay. Now we can also sort the records based on values using this function, and it provide an argument with the name by equals. Okay, so this is something that we did not discuss. In functions, you could also, instead of just order, we could also pass the keyworded arguments. Okay, and we could use the keyworded arguments in the functions. Okay, so here we are passing the keyworded arguments, as in we are giving the name and value instead of just a list of arguments. Okay, so here we are saying that sort the values by a particular column called age, okay, and in place. Okay, so it's going to order the data based on age, and since it has done in place, therefore the whenever we access people, it's going to be in that order. Okay, we can plot a data frame simply like this. We can say, okay, we can body mass index is there. Yes. Yeah. So we can simply plot a data frame in this manner by saying the data frame dot plot, and we say that what kind of plot are we looking for? Are we looking for lines or only dots? Or we are the on axis this will be there, and on y-axis these are the columns that we want. Okay. So we can say plt dot show. What does it say? It says y equals height and weight. Height and weight is not there, or it is there. Which one is missing? Let me see. Did I delete something here? Oh, body mass index is not there. We did not compute this. Okay. So you can see that the data set, let me just show you this. So here, this is our data set. Okay. And we are saying that draw a line, and on x-axis, keep the body mass index, this 32, 22, and 25. Okay. 32 and 225, yes. And on y-axis, keep the height and weight. On the y-axis, these are the height and weight. All right. So as body mass increases, the way as the weight is as the weight is decreasing, the body mass index increases. All right, that's what it shows. All right, so we can save and load the data frame from the files. Here, let's say it'll take maybe 5 more minutes. Okay, so I hope that's okay with everyone. And so here we are creating a data frame using the standard way, using a list of lists. And we are specifying the name of the columns. And we are also specifying the name of the index, the name of the rows. Okay. And this is our data frame. So we have, let's say we have simply created a 2x4 kind of a data frame having these values, and we would like to save it to the disk. We would like to save this to the disk. So what we will do is we will say to CSV. This will save the data into the disk, into this file. Okay, and this will save the whole data frame in the form of HTML. This will save the data in the form of JSON. If you want to take a look at the current folder, you can see that there is already something there. Okay, did the git push. All right, let me just delete my older data. Do you know that in the Jupyter notebook, you can delete the file using exclamation. So here you can call the Unix command using exclamation. So okay, I'm saying rm, and these are the files. Earlier I said exclamation ls. It shows me the list of files here. Okay, so I'm going to delete these files. So here I go. This, I'll just delete all of these. Okay, now I'll say again. So you can see that these files have been deleted. Now let's call these functions to CSV, to HTML, to JSON. Okay, so you can see that if when I executed ls again, these files have been created. Okay, let's take a look at these files. Okay, because the files were existing, so that's why I'm deleting these files, just to see that, just to show you clearly that it really created a file. Okay, so here all these files have been created. Okay, so let me show you how does it look like. You can see that here it has saved it. Using the cat Unix command, you can take a look into a file. Okay, so all right, what does it mean? Let me take a step back and explain again. So data frame is in the memory, and whatever work you did, if you do not keep it somewhere, as soon as the program is going to exit, the the data frame and everything will become blank. So so it's better to keep them at somewhere, and that's where these functions to CSV, HTML, and JSON exist. So to CSV converts the data frame from the memory into a file which is comma separated values, while to HTML converts it into tabular format, a very well defined tabular format, and this one converts your data frame into JSON format. All right. You can take a look at these files using cat or using your Python file open. Okay, you can take a look at that. And you can also read a CSV file later using read CSV. Similarly, read JSON you can use to read the data from a CSV file or any other file. Okay, so using head function, you can take a look at the top section of the values. So here what we're trying to show you is using pandas, we are reading a file called housing.csv, which is located in datasets. Okay, and when we say housing.head, it is showing us the top 5 records, first 5 records from the data frame. If you want to take a look at the last 5 records, we could use tail and also pass an argument such as 20 or some other value, those many records that you want to access from the end of the data frame. Also, to take a look at any pandas frame, you can simply say info and it will show you all the details about the the data frame. So it is showing you that these are the various columns, and these columns have these many records. Now, to get to know about a data set or a data frame, the best one is to use describe function. Describe function tells you count, mean, standard deviation, minimum, and then the quartile, as in 25% of the total values, and so on, right? And the max. So using describe, you can quickly take a look at the entire data set easily from a statistician's perspective. Okay, so using the describe function, we are able to see what's going on with this data set. So you can see that there are these many. Okay, while there was this table, we will actually cover this again. Okay, there are these many columns here, but we don't know what is their range. So we use describe function. This is very similar to a summary function that people use in R or other languages. Here in using describe, we are able to quickly see their mean, standard deviation, minimum, maximum, and count, how many values are uh, till what point is 75% of the values um, are, and till what point half of the values are, and so on. Using this describe function, we can see that. Also, we have covered the pie plot quickly earlier also. So in very simple words, before you plotting the graph, all you need to do is import the pie plot and then plot the graph using the plot method. And then you can apply labels and other things. Okay. And also, if you want to take a look at the various function, you just press the tab here. Okay, I just press a tab here and it is showing you all possible values. Okay, so we can draw the graph using pyplot. Okay, Bindav's question is the housing.csv does not exist. Okay, what I'll do is we will make this data set, we'll commit this data set into the GitHub. Okay, or is it committed already? It is not committed yet. It should be committed. Okay, let me just see if it is there. In the Python folder, do you see dataset here? Okay, thank you, Noor. All right. All right. So using plot, you can plot the graph very quickly because it's important to understand data using graph, because a lot of data, when you look at the tabular format, it doesn't make sense. But when you plot the graph, it makes a lot of sense. Okay, even the equations, the mathematical expressions do not make much sense until you plot a graph. Therefore, it's important to learn to plot graph, and it's actually extremely simple. Okay, extremely simple. So either you could just give a list and it will automatically take that list, okay, so I'll show you what it means. So you can see this is the graph. Now the this is the y value we are passing. X value is by default 0, 1, 2, 3. Okay, and if you want to provide the x value as well, we can provide that using this. So you can see that the the y value is the first list and x value is the second list. A question from Noor is, why do we have to use matplot when DataFrame provides its own functions to plot a graph? Because your data may be in a normal Python list or it may be NumPy. Therefore, it is better to learn to use the pyplot. Okay. So plot is the main method, but remember that after plot, you must call the show. Okay. And here, let's say we have some numbers and we are trying to prepare the histograms. Histograms is something that saying that give me these many buckets, and it will basically prepare those many buckets based on the range of values. Okay, so here are basically numbers. X is nothing but a list of numbers, and we are saying that give me 5 buckets, and then we are preparing the histogram. Okay, so you can see that from 0 to 20, these many values are there. From 20 to 40, these many values are there, and from 40 to 60, this is the uh, total, and from 60 to 100, this is the total. Okay, so all right. So histogram is nothing but counts of values between the ranges. Okay, between the ranges. So here you can say that between 0 to 20, how many values are there? 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. Yes, so there are around 9 values, right? Between 0 to 20, correct? And say 80 to 100, how many values are there? 100 is there and nothing else. So there is basically the one value. Similarly, 60 to 80, how many values are there? 60 to 80, there is only one value called 77. So it is basically showing you the histogram, meaning how many values are there in a particular range. Right? So that's pretty much about basics of the basics of the libraries, Pandas, NumPy, and we briefly touched upon the plotting of graph. And we will take a digression in the course if we need to learn any other thing in the midway. For example, if let's say we want to learn statistical inference, so we will basically take a brief digression at that point and quickly cover only that part. Okay, because there are just if we start picking up say linear algebra in too details, it'll be too boring and we'll not be able to learn and stay focused. Okay, so whatever concepts we face as we go ahead, we will learn then and there and then move ahead with the subject. If there is a need of explaining or teaching differential calculus, we will do that during the course. Okay, we will do that during the course. And so tomorrow we are going to have the first session on machine learning. Okay, tomorrow we are going to have the first session of machine learning, and then from the next Saturday onwards, what we're going to do is we are going to work on the first problem hands-on, where we will take a problem, and then we will go do the end-to-end analysis of it. And while we do that, we will learn rest of it automatically. And then after the hands-on, we will talk more detail about the theory. Okay. So tomorrow we have a introduction to machine learning session, and then next Saturday we'll have the hands-on exercise on hands-on on with machine learning, taking one problem related to the housing itself. Okay, so a question from Bindao, can you recommend me a Python textbook? Yes. Something that I found good is one, the main documentation of Python, that is my first choice. Okay, so let me make a note here. All right, so my first choice is Python's core documentation. Okay, second is I prefer just searching on Google. And third is actually main documentation. There is really wonderful tutorial. Okay, that's really good. Then third one that I liked was a book called Learning Python. Okay, these are the three books that should basically when you finish the tutorial itself, that should be good enough. Other than this course has already covered most of it. Okay, so when I say main documentation, if you say Python 3 and you go here and you click on the docs, so here you'll see a lot of documentation. There's a beginner's guide, there is frequently asked questions, and so on. So this specifically the library reference is something one must get used to it. And the same you can also explore using here. So if we want to say learn about say all the functions of PLT, so what I'll do is I'll say help PLT and it will tell me all about this module. Okay, this is far more comfortable for me. So you can see that it is given an example of how to plot the graph here. So okay, so you can see that I've just plot a sine graph. Okay, so get used to this, the main documentation, and this should be of much help. Okay, and the standard reference is also pretty good. Okay, and it helps us. There is a standard format in which it is displayed. So once you kind of finish reading the documentation of one particular thing, you will get used to the documentation, and rest of things will become far more easier to you. Okay, so yep. Acosta is suggesting any specific reason you moved from YouTube Live to Zoom. The reason was that there was always a delay. I had to ask a question and wait for some time, and because of which the course actually got delayed. Okay, and yes, that was one of the biggest reasons of moving from YouTube Live to Zoom. Second reason was that I wasn't able to share the code quickly, and the users were not able to share code quickly because it was blocking the chat. A question from Binda is how to copy housing.csv into my Jupyter notebooks. If you are on CloudX Lab, what you can do is you can just SSH and do git clone. Okay. And what you can do is you can go to the file browser. You can go to, say, view toggle header, go to control panel, go to my server, and there you will see that there is this file browser there. Using that, you can also upload. If you are not doing git clone, you can do upload also. All right. To understand your present working directory, what you have to do is you have to say exclamation pwd, and you will know which directory you are in. A question from Gopinath. So will the machine learning be activated? It will be activated soon, Gopinath, as we move ahead. Okay. So what was I saying? You can say exclamation pwd. It'll show you the present working directory. For me, the present working directory is this one. And the data set should be in this folder. All right, so I hope that answers your question. To say one more thing, in the Python one, there are two projects I have put in. These are real projects, and this is something which we recently did for ourselves. Okay, and so what we're doing is here we are doing the analysis of our inbox. Okay, we're doing analysis of our inbox, and for that, to get our data from Gmail to our local disk, we are using a tool called Got Your Back, GYB, and using that, we will just download the data locally, and then using Python, we will be able to we should be able to process the emails. Okay, so these are the two projects which are part of this course, the foundations course, and there are these interesting questions that you need to answer you will be able to answer based on this data, such as who is your closest friend. Okay, based on email, but based on your email, you can figure out that who is your closest buddy. So those kind of these are the two projects that you need to finish. These two projects are interrelated, and you should be able to achieve them very easily. Okay, so use Python to do this, and these are quite meaningful projects. They are not arbitrary. Okay, all right. So finish these two projects, and also we are adding exercises as we move forward. So we have added quite a few exercises which you should finish. Okay. All right. So thank you, everyone. I hope to see you tomorrow again. Okay. Where and how can I obtain project materials? You can just log in into CloudX Lab, and in your My Courses, you will see this. Even if you have not taken the subscription, you should be able to see Python My Course. And just that you will not see the lab on the right-hand side. Okay, but you should be able to see these problem statements. Okay, Python course. All right, feel free to reach out to us at reach us@cloudxlab.com, and I look forward to see you all. Thank you, everyone. Bye bye. Have a good day.